We can use proportions when we need to solve an indirect measurement situation. And what that really comes down to is that maybe there's a distance in real life that's very difficult to actually get a true measurement, and then we can set up a scenario where we're using similar figures to build a proportion, and then that gets us the information for that measurement without having to get a tape measure out. So let's take a look at example 1. I really recommend that you draw a picture to represent this situation. So a boy is 5 feet tall and casts a shadow that is so many feet long. Well, that's a typo, so we need to go immediately and say, hey, it's 15 feet long. So let's go draw the boy and the shadow, and let's make sure we do a good job labeling it too. And in case you're wondering where we're going with this, the boy is standing at 90 degrees to the ground, so technically it's like a triangle is formed from the top of his height, right there at his head, all the way to the end of the shadow, and it makes like a right triangle, but really we just need these two lines to help us show this. Now, a nearby tree casts a shadow 75 feet long, and so since I know the length of the shadow, that lets us be able to draw a tree with a 75-foot long shadow, and it says find the tree's height. So I'm just going to make the tree's height an X, so let's go draw that. So we've got our diagram drawn here, and now we can actually just use the same thing that we did for similar figures. Let's just build a ratio with the boy's height to the boy's shadow, 5/15. And it's probably going to be good if we actually make a little bit of notation off to the side on this first ratio so we can keep track of what is what. Remember, this is the actual height of the object that we're looking at, in this case the boy's height, and this is the length of his shadow. Now we can come right over here and just make our other ratio. We know that both of them are going to be in feet. The tree, we don't know what its height is, so that's going to be X feet. But the tree's shadow is 75 feet. And so since we have shadow on the bottom, we can put 75 feet shadow right here. Hopefully the color coding lets you be able to see how we transferred it from the drawing over to the proportion. Now we just need to cross multiply and we'll be done. So 15 times x is 15x. 5 times 75 is going to be 375. And so after we have this cross multiplication set up here, just come back through here and just divide both sides by 15. 375 divided by 15 is 25. And because this is a story problem, and they had said, hey, would you please find the tree's height, right? We just need to do a restate.